We're good. Welcome to Module 2, the second class of Introduction to Python with me, Yaakov. Let's just go into it. Let's just go. Here's my coffee. Okay. You're a programmer now. You can drink coffee whenever you want. Okay, so this is the GitHub link that you will have access to. Well, it's open. You can go find it. I'm going to share you the link. So here's Module 1. You can get caught up with that here. Here's Module 2, and I added a little bit of notes. This is the data that we're going to be getting. So to use it, you're just going to copy paste it. Okay, let's just go right into it. So you're going to open up Module 2, let it load. There you go. So there's a whole bunch of stuff here, and let's just open up in Colab. Okay, Colab is going to make a copy in your notebook. It's going to make a copy in your drive, and what you're going to do is you're going to connect. And before we do anything, we just want to run one cell. Okay, and we have to give it permission. So it's loaded, give it anyways. Okay, cool. All right, so now we're up and running. We're in business. So let's just go over a few very quick things. Python is programming language. You already know that. This is a notebook, so you can write it in like what looks like code, like those like black backgrounds. A notebook is different in that the code doesn't sit somewhere else and hit the compiler. What happens is you can put code in little cells, which are here, and then if the code does something, you can see it right after, and you can give yourself little hints. It's really good for data analysis and data manipulation, because as you take things apart, you can kind of see what they do. You'd be like, oh, I wonder what happens if I don't know, choose this, and then boop, it happens right there. Cool. So let's talk a little bit about what the project, what we're going to be learning today and what the goals are, okay? So the goal is to interact with data. So hopefully by now you understand the different types of data. You understand lists, strings, dictionaries. And so now, instead of just learning about them, let's use them. So we're going to be using text from Shakespeare's The Tempest. The full script you can get through this link. And I built a scraper that basically went to this site and parsed all the language and broke it down per character. Turns out the parser is very difficult, so I only have it for the first two scenes. But we've got some real data, and we're going to tackle some real problems. So step one, load the data. We're going to navigate our dictionary. So our data is stored in a dictionary. We want to basically move around and know where things are and get stuff. The next thing is we're going to parse textual data. And I don't say language. Textual is the words that make up language. I don't say language because language is complicated. Textual is like parentheses and periods and words and characters. So that's what we're going to be doing. And then we're going to analyze it. And so we're going to analyze a whole bunch of stuff, and then we're going to try to make some conclusions, okay? I already made some conclusions on my own. Let's see what we come up with together or what you come up with on your own. So let's take it from the top. Module 2, interacting with data. So we've already done the introduction. So importing data. So if your data is very small, you could just code it yourself, right? Like you could say my favorite food equals pancakes, which it is. So that's really easy. But what if you've got a huge play? You're not going to type that in manually. That's crazy. So that's what we're going to do here. We're going to import it. All right. It's not really important for you to understand right now how this works, what's happening in this code. What's important is you understand that you're hitting a URL that's going to contain a whole bunch of data. And if you want, you can just look at it yourself. This is going to be on storage Google API, and here you can see this is a bucket I've created, and this is what the data looks like raw. It's pretty ugly, it's a mess, but this is it. I mean, if you ever wanted to read a play as a computer, this is a play. Wonderful. Okay, so we're gonna get this little guy here, and now we're done. All right, so make sure you run that. Just double check. You can run it more than once. You're fine. Okay. So now we're going to navigate our dictionary. So remember, dictionaries have keys and values, right? The keys are the things that I want to use to look things up. So before I even run anything, I'm going to create a new cell. I'm just going to print my data. I just want to see what it looks like. Holy crap, right? It's a mess. So I can just say, what's the type of this? You already know it's a dictionary, but let's see what it is. It's a dictionary. Well, dictionaries always have keys, right? So what's my keys? Okay, Act 1. That makes sense. We're dealing with plays. So I know that Act 1 is probably going to contain all the information for Act 1. And it does. It's got a ton of stuff. So let's get the keys for that, right? What do you think the keys are for Act 1? Well, you got Scene 1 and Scene 2, right? And so on. Okay, so now that you know what, and let's just see what Scene 1 looks like. It's going to look very nested as well, right? And, whoopsies. Okay, cool. So now you see a little bit, something that looks a little bit more like a play. And let's just get for the character Alonzo. Okay, cool. Now that looks a lot better. I see all the things he's done. He's done this in this Act 1 and Scene 1. He has no action, and he has one line. His line is, "Good, boatswain. Have care. What's the matter? Play with the men." Wonderful. Okay, so let's get rid of this guy. When we talk about navigating a dictionary, like I just did, we first need to understand nested structure. So what nested means is something inside of something else. A useful method for storing lots of dependent data. So what happens in Act 1, Scene 1, it only happens there, it doesn't happen other places. So it's dependent, right? Versus my favorite food is always my favorite food, unless it changes. Which it definitely does, but let's just say it doesn't. So you want to use nested dictionaries, and the dictionary at hand, data, is structured as follows. So here's the structure of the thing we're working with, okay? At the very beginning, you have acts. And if you're in theater, this is going to make a lot of sense because this is how you write a play. You have an act, then inside an act you have a scene, right? And in the scene, you have the following keys. You have settings and characters. And we can double check that ourselves. We will be, if you hear the sirens going by. If we're going to investigate them soon. So in each scene, you have setting and characters. Okay, the setting is not nested. That's just going to be the setting. The character is going to contain, it's going to contain dialogue and action. And both of those are going to be lists. And it's going to be all the things they said and all the things they've done in the order they said them. But the dialogue and action is only structured in a list, right? So I don't know which character said what line first. I just know what each character said in order. Okay. So let's go, and this is what it looks like in bullet point form. Okay, each act contains scenes, each scene contains setting and character, each character contains dialogue and action. Setting is a string value. Setting is just going to say, the setting is a boat. Okay, dialogue is a list of strings. It's going to be all the things they've said. And action is a list of strings. It's all the things they've done. Cool. So wait, oh my God, Yaakov, wow, you made me learn all these numbers and floats. I can't believe it. I wasted all my time. That's for the end. That's analysis, right? So data, you play with it. And that's what we're going to do. We're interacting with data. Hey. Okay, so we're going to open up this thing, and let's go. So to understand the structure of the data, we first want to know acts, scenes, yeah, and then characters and dialogue and action. So let's go. So I'm going to print all the acts. There's only one because I didn't get around to doing all the work. Let's see all these scenes in Act 1. So I'm going to say data, get me Act 1, right? And give me all the keys. There you go. There's Scene 1 and Scene 2. Notice how Act 1 and Scene 1, some are Roman numerals, some are numbers. Long term, that could get you in a little bit of trouble. But for now, we're just doing it because that's how the website did it. And we're not making up rules here. Okay, what are all the keys for Scene 1? Here we go. So I've got the setting at the start. And then I've got a whole bunch of names. These look like the names of people, and they're all in title case. Title case is the first letters capitalized, and the rest are lowercase. So that's great. It means I've almost got to the things where I need to be. Let's see all the keys for Master, who's the Tempest. He's the king who dies. Oh, spoiler from Act 1, Scene 1. Okay, so here are the keys from Master, right? So this is going to be a dictionary. So here, this is a dictionary. This is going to be a list in a dictionary, in a dictionary, in a dictionary. Woo! Dude, I'm telling you, it's like the Matrix. So, okay. Let's look at what that dictionary looks like. There you go. So, the master has two actions. He leaves, and then the mariners enter. And he says two things. He says, boatswain, and good, speak to the mariners. Fault it yearly, or we run ourselves aground, Bister. I'm not the best actor, so I might be butchering that. Okay, great. So we now know how to navigate through our dictionary with its nested structure. Close that, and let's do some more heavy lifting. Okay, so we're going to loop through nested objects. What does that mean? Well, if you have a list, you want to go through each thing. With nested objects, there's an extra, you have to be a little bit more careful. Because when I say, go through my list of favorite foods and do this manipulation, I know that each food has the same form. Well, with nested structures, sometimes things aren't how they're supposed to be, and you have to build into your code precautions. So let's give that a look, okay? So I want to print out all the characters who are in Act 1, Scene 1, okay? So I'm going to say method 1, okay? First, let me show you what it looks like without any method, okay? So I'm going to say for key in Act 1, Scene 1, print key, okay? Hey, what's settings doing there? Settings is not a character. So a solution long term is when you build your dictionary, put in setting and then have that a value as a dictionary, and then have a dictionary characters and then have another dictionary. But extra nested structure, we can still work with it, right? Nothing's ever going to be perfect. So what we need to do is we need to get rid of this guy. So here's how you can do it, okay? Let's go back down here. Method 1, I'll say for key in the keys, right? If the key does not equal the thing I don't want, which is settings at start, then print it, right? Give me everything except for this guy, and it works. Those are all my values. That's wonderful. And this is a string match. I'm saying if this guy does not equal this exact string. So what happens if I make something capital, right? It does show. So that's why string matches aren't great. Okay, what if I also have many things? What if I want to exclude also, I don't like master, I just don't like him, right? So how do I say and this, right? So that brings us to method 2. Okay, method 2 is if it's very similar to method 1. It says if the key is not in a list of things. So if it's not in here, and now I can add or master because I don't like him. He's gone, right? I could just start adding people to this list of ignore these guys, right? Okay, but we want characters. So that's the second method, string list match. Okay, let's do method 3. Now both of these methods have their strengths and weaknesses. This one, the method 1, really easy to write. That's great. Method 2 is I can have many values, so I can screen for quite a bit. But both method 1 and method 2 require me to have proper casing of my key. And also, what if I have setting at the end, setting in the middle? What if I add stuff later and I just don't want it? So method 3 gives us a way of avoiding that. This is a little bit of a workaround. It's a little bit clever. It says like this. Notice how all the characters are title case. So take your key and make sure that it's title case. And if it is, print it. All right, let me show you what that looks like outside of this. So I'll say fave food equals pancakes. Okay. Great. Wait, this has to be code, not give it code. Yeah. Okay, my favorite food equals pancakes. So if I do fave food, I can say give me title case. And title case is going to make it pancakes. I can also say upper, right? So pancakes. So I could say like this, title, right? So is pancakes title? I'll say fave. I could say fave foods equals title. And it's going to say, no, it's not, right? It's not this, it's not title. How about lower? Is this equal to lowercase? Yes, it is, right? So that's a really simple way of screening for things. So I could just say, take the keys, take all the names, and if they're title case, then keep them. And that works. That's actually a quite clever way. I would say this, like if I were interviewing someone to work for me, which I need money, I can't wait to hire people. But if I was hiring for someone and they wrote a method like this, I'd be like, eee. But if they wrote a method like this, I'd be like, eee. And then here's the final method. Method 4 is going to be on fire, right? So method 4 solves an additional problem. Method 3 says, yeah, I know I have characters, and I only want characters of capital letters. Wee. Method 4 says, I don't even care. What I'm going to do is I'm going to do some manipulation on a character. So I really just care about the value. Is the value going to be a dictionary, right? Because remember that each of these things, each of these values, let's take a look at master, right? Master is going to be a dictionary. But let's take a look at setting. Let's take a look at this whole guy's setting here. Setting is going to be just a string. And I don't want strings. So look, like I don't want this guy. So I'll just say like this. For key value in items, remember the method, I don't have to do key, get the key. So for key value in items, so the key is going to be the name, the value is going to be what it is. If the value is a dictionary, then keep it, right? And so that works. And that's better. It might be slower than the other methods, but this method doesn't even care what your key is supposed to be. All it says is, I need a dictionary. I don't care what you are. Even if you are a character, but you don't have the right attributes of a character, out of here. So these are the different types of ways you want to think about writing your code. And I would say method 4 is the best way. It's kind of ugly, but once you get used to writing it, it is beautiful. So that concludes our chapter, our method 2.2. Don't tell me that's it for 2. Wow, we're done already. Phew, we're flying. Okay, so we can just close the whole second guy. We're done navigating. We're pros. Let us go into parsing textual data. So if you need to get a cup of water, right now press pause and go get your thing to drink, because now we're going to get busy. Number 3 is going to be some heavy work. So put on your thinking cap. All right, so parsing textual data, words and stuff. Pretty simple. I want to start off by getting all the characters in each scene, okay? So here we go. I'm going to say go into Act 1, items, okay? So what's going to be helpful is by understanding what each thing is going to print, okay? So here's what I'm going to do. I'm going to just comment this whole thing out, and I'm just going to print the key, okay? So what do you expect the keys to be in this for key value in data Act 1 dot items? 2, 3, 2. Okay, they should be scene 1 and 2, right? Because those are the keys inside. Okay, so what we're going to do is we're going to rename the key variable scene. Okay, because I want this to be meaningful. A key doesn't really mean anything. Scene is important. Scene tells me something that means something. Okay, now my value is dictionary, right? And the dictionary is going to have settings and characters. So I'm going to say for KV, this is a good way of getting nested, right? I don't have to say the whole thing, but I understand I'm going to a dictionary in the value items. And now I want char to be my character. I want K to be my character. Remember how last time, sometimes K is going to be setting? So I'm going to use this method as well. I'm going to say, if the type of V is a dictionary, then print character. And here we go. There it is. So this is your time to press pause if you don't understand what's happening here. Kind of play around with things, see what happens when you change some code, and see if you understand what's going on. But here are all the characters per scene. Great. So, but this just tells me blah. It doesn't tell me which scene they're in. So here's what I'm going to do. I'm going to create a dictionary. Saying I'm going to make a dictionary, right? Instead of printing them, let's store them in a dictionary. So I'm going to make a dictionary, all the characters, right? I'm going to make it an empty dictionary. Remember, a dictionary has curly brackets, a list, square, dictionary, curly. Well, my hands don't really do the job well. Okay, we're going to do the same thing as last time, right? This is a very similar code as last time for key value in Act 1 items. And then I'm going to say my scene, equals the key. Okay, so now I'm going to say all characters, which is my dictionary. I'm going to add the key that I've just made, which is scene. So now scene is going to be an empty list. And if I just comment out all of this code, and I just look at what's going on there, I'm going to have scene 1 and scene 2 as empty lists, right? Because that's all I've done. Okay, and I would really recommend you, if you don't really understand what's happening, to comment things out and just print them out and see and understand what's going on, right? So if we print out scene, here we go. I'm just going to see scene 1 and scene 2. So I'm like, yeah, that makes sense. I can add them to my dictionary as empty lists, right? But wait, I want to see what this looks like every time I print it. So I can say, okay, print this each time, right? So first it starts off with scene 1 as a dictionary, then it prints it with scene 2. Easy. Okay. And now some of the more intense stuff, right? For KV and the values, so these are going to be all my character names, right? So character equals K. If the value is a dictionary, like we did last time, you can also use any of the other methods that we did. If K equals string, whatever thing, okay. Then, if type V is a dictionary, so if my character is a character, then go to the list I made. Remember that list I made right up here? And you're going to append the character. Append means add it. Okay? There's other languages have different words like push, but if you take a list and you plus and you add something, it's not going to do what you want it to do. So the best method is to append it. Okay? And append is just going to add something, and that's going to give us this. And I'll give you an example. I'll just say foods equals, I'm going to make this a list, okay? So if I just print this, it's going to be empty, okay? But if I append it with so many options, gushers, which are really good, then now my thing has gushers, okay? With appending, you can only do it one at a time. You can't do many things. I could do pineapple. I'm not spelling this right, but okay. Pineapple. There we go, another list, okay? And I'm not going to talk about how to extend more things with lists, but the basic is delete, go away. There you go. So when I append it, I'm adding it to my list. And so now, if I just print it, I have all the characters in scene 1 and all the characters in scene 2. And I won't go through with you what I did earlier today with the people who called in live. We checked to see if any of the characters were in both scenes. They aren't. And that's pretty typical for some Shakespeare stories because he likes to start with stories that take place in what seems like two unconnected lines and bring them together to show some ironies or how high the wicked fall, or these very big metaphors. And also it helps if there's time between the two, and you get to figure out who's connected. So that's one thing we really love about Shakespeare. Okay, so here we go. And also you can look at some of these names, right? A lot of these names look the same. Alonzo, Antonio, Gonzalo. This might tell you something about them, right? Like you might think that they're, I don't know, cahoots together. And also, I mean, I can't tell you something so much about the meaning of these words, but I'm sure you can develop some concept like, oh, when a Shakespeare character has this sort of language, then you know these things about them, which is what we're going to hope to do at the end of this. Okay, so we're done getting all the characters per scene. That was heavy. Now let's go a step further. I don't want to just get the characters. I want to get all the things they say I want to get all the things a certain character said. Okay, so here's what I'm going to do. Instead of referencing the dictionary over and over and over again, I'm just going to store the values in a dictionary called characdict, which is going to be my character dictionary. Okay, and I'm just going to comment the whole thing so I can see what character dictionary says, okay? So characdict, we saw this earlier, right? It's going to be dialogue and then the action. Great. So I'm going to get rid of this guy, and I'm going to say, all right, what are the keys of my character dictionary? You should already know what this is, right? We did this earlier. The keys should be action and dialogue. Yeah. Okay. And what are the data type for each one? So we're going to say for key in character dictionary keys, value equals, get me the value, right? Look up the value for this key and print out the type. And they're both lists. Well, here's an alternative way to do it. Right? If you're like, hold up, Yaakov, I heard that's not the best method. What about key value and items? Bingo, right here. And we took 3 lines of code, and we made it 2 lines of code, which, I mean, your goal isn't to reduce code, but this is best practice. Okay, so we see that the things inside this are both lists. Great. So let's print out, what are the dialogue here? Right, there we go. What is the length of the dialogue? How many lines does this character speak? Right? So these are individual times this person comes onto the stage and says something. So Master comes onto the stage twice. Okay. Well, it looks like it's a response, but he has 2 times that he talks. That's not a lot. Okay. How many words does he speak? So here's what we're going to do. All right. If I'm going to take a sentence and I'm going to say this slice of pizza is amazing. So I'm going to say, this could be my text, okay? So how many words are in text? Well, first let's count it, okay? 1, 2, 3, 4, 5, 6 words, okay? So if I want to find out the words, I need to split them, okay? I'll split the words. The default is to split it by an empty space. I don't have to do that. The default is to do that, okay? And so here I have a list. So I can just take the length of my list. And the length of my list is going to tell me you've got 6 things in it, right? So there's 6 words. So this is how you take the length, the number of words in a sentence. So let's move on to the next cell. And if this doesn't make sense, press pause and play around with that. Okay. Let's go. So how many words does he speak? So for X in character dialogue, then we're going to split this method. And I'm going to do 2 things. I'm going to show you the number of words, and I'm going to show you the words that he said so you can see them next to each other, okay? So here, the first time he speaks 1 word, and the second time he speaks 15 words. Great. So this tells me how many times he speaks per line, but I need to know all of the words altogether. So here's what we're going to do. We're going to say number of words is going to be equal to 0. He doesn't say any words. Now go and do the same thing you did earlier and get me n. Get me the number of words he spoke, right? So n should be 1 and 15. Then take the number of words and add n to that. So I'm going to say, let's just say it's going to be 0 equals 0 plus 1. Then you go to the next one. 1, well, this variable equals 1 plus 15, right? And so if I do that, it should be 16. Yep, bingo. And this little thing here, there's an easier way to write it. But first, let me show you what it looks like when you play around with it. Okay, so I'll say n equals 10, okay? So if I want to do n plus, so I want to say 4x in, and I'm just going to say 100, 100, 100. Okay? I want to say x plus equals, give me n plus equals x. So I basically want to say, take each one of these and add it to n. All right? So if I print n, it should be 10, 110, 210, 310. Cool, that worked, right? What if I want to say, if x equals, if x is less than 100, less than or equal to 100, well, let's just say if it's equal to 100, then add it, right? Boom. This is why it's really useful, because I'm not just doing adding or subtracting, I'm doing complicated logic. So plus or equals is basically a way of keeping track of everything. Okay, so here we go. Here's my second method. I don't have to write n words equals this whole thing. I could just do it with plus or equals n. And I'm just going to do this. So number of words is 0. Go through each word, get me the number, go through each line, get me the number of words, then add that to the total number of words and print 16 words. Easy. So we have the number of lines, the number of words. Let's get the number of characters. Turns out that's really easy. I'm going to do a very similar loop, but instead of doing length x split, I'm just going to do length of x. Okay? And length of x is going to be just the number of individual characters. Now, there's going to be a few issues that we're not tackling. We might be parsing certain words that are not words, like maybe there's colons or dashes. We're counting spaces in our characters. We're counting apostrophes and all these other things. And to that, I'd say it would be amazing to correct those things. Those are actually really complicated, and that's what data scientists spend a lot of their time doing. So if that's interesting to you, keep on learning, and you'll get there. But for now, let's just say that this suffices, okay? Because we're not really we're not building a chat bot, or we're just having fun and learning. Great, so we're done 3.2. We're done getting all the dialogue from a character. Let's get the action from a single character. All right, so we just did that for dialogue. So let's do it for a single character. We're going to do a little bit more advanced techniques here, okay? So I have a list of what each character said and what they've done. So I'm going to start off with the character Gonzalo. I'm totally not pronouncing his name. Let's just Google it, Gonzalo the Tempest. And it should please tell me how to pronounce this. I really want to do injustice. Gonzalo. There we go. Oh, we got a picture of him and everything. Wow. He's one bad dude. Or is he bad or evil? I don't know. He's cool. All right. But I love this. I want a hat like that. I feel like this is what Dumbledore wore before he got old, right? Okay. So we're starting off with this guy here. Okay. So we're going to say, okay, go into my dictionary, go into data, get Act 1, Scene 1, and get me the character. It turns out I'm not even going to do this. All right, just get me the character. In fact, I don't need to do .get. I could just do square brackets. Okay, but we'll just continue with .get. And you don't have to erase what I had. That actually works just fine. Okay, so I'm going to say get me the character dictionary. And what I'm going to do is I'm just going to comment off this whole thing so we can see what it's doing. Okay, so let's do print character dictionary. All right, there we go. And that's the thing. Always speaks a whole bunch. Love that. Okay, so we're looking up his actions, okay? So we're going to get all of his actions here. And now we're going to uncomment it, okay? So here's all his actions, all right? And we're going to start off with no words, no characters, and no instances, which is the number of lines that he comes up. I don't know. Instances was a very agnostic variable. I think it's not ambiguous. Okay, so this is all the stuff we're trying to do. And as we go through, we want to add to all these guys, right? Okay, so for each word, for each line and character action, We're going to split the words, right? Here's X words. And if you wanted to print the words and see what they're doing, you can just use this, okay? So N words is going to be the length of word split, the split, right? And characters is going to be X. So with words, I split. With characters, I don't split. And this is going to give you both of these values, okay? And let's back up a step. I skipped over something. So let's just start from the top, right? Character, Gonzalo. Go and get his dictionary. Go and get his actions, okay? The words start off as 0. The characters start off as 0. The number of times he comes onto stage is going to be equal to the number of things I have in the list of things he's done. If he came on 3 times, just take the length of that. Great. I'm going to go into all of the lines, and I'm going to get the words. I'm going to add that to the number of words. I'm also going to add the number of characters to the length of the lines. And now I'm done, okay? So I'm going to just print, well, I'm almost done. I want to look at this information in a neat way. So I'm going to say, I'm going to create a new dictionary, all character actions. I'm going to make this a empty dictionary. I'm going to add to this dictionary my characters. So Gonzalo equals, and all these things. And I'm going to print it, okay? So here we go. Gonzalo, has 184 characters. He comes on stage 3 times, and he has 25 words. So that's pretty interesting. And that's all from here. So I would say, if you understand what's happening, let's move on. If you don't, press pause, maybe rewind, or maybe just play around and see what's going on. Actually, yeah, I'm just going to explain one more time what's happening here. Here I'm creating a dictionary, right? So I'm creating a dictionary that's empty. And then I'm adding a key to this dictionary. The key is going to be the name of the character, which is Gonzalo, okay? And then this key is going to be equal to a new dictionary. You see that? And in that dictionary, I'm putting in these values. Okay, so now you're going to press pause and take a look back if you need to look this over. Otherwise, close section 3.3, we're on to 3.4. We just did that with one character. Let's do that with all the characters. And this is why you'll understand why iterating is very useful, because I don't have to do it one by one. I can write some code, and it does it for everyone. Okay, so all data, let's start off. All data is going to be an empty dictionary. Okay, what's the thing I want to look up? I want to look up action. Okay, so for key value in my data act 1, scene 1, go through all the items. Okay, make my character my key. Now, skip if it's not a character. Now, create an empty dictionary. This looks familiar. Then, you're going to take a look at the dictionary that we've made. So this is going to be, let's just say Gonzalo's dictionary, right? And X look of his actions. So only get me the actions. So for each action in the actions. So for line, right? So X is going to be the line. I'm going to say the number of words is going to be X split. This you know. All right, count the words is going to be split the words, okay? Count the characters. And we don't want to get rid of spaces because we already went through that. So this should be very familiar. X split is the number of words. Length of S is the number of characters. I'm almost done. And now I'm done doing my for loop, right? At the end of my for loop, so I'm outside. So this is in the for loop. In, out, right? So I'm out of my for loop. And I'm going to say all of my, I'm going to say, right, here's my dictionary. Add a key. Make my character, so let's say his name is Gonzalo. Make Gonzalo equal to the thing I just made, right? Here's the character dictionary I just made. Add that here. And do that over and over and over again. So here's the first for loop, right? The for loop is going to go through all of the characters in scene 1. And this is going to go over all the lines that they say. And they get added at the end of the for loop. So if this makes sense, you just give it a run and you see what it looks like. There you go. If you want to troubleshoot things, you could just uncomment this line, and break will say stop. And stop means it's just going to stop when you get here. So it's only going to work for the first line, right? Because master goes through. Master will say for key is master. I'm going to say is the value equal to, well, the first one is settings, but we skip that. So the second one is key is a master, okay? I'm going to say number of words, the time he speaks. I'm going to do this whole thing. And then I'm going to add him to the dictionary, and then I'm going to break. Right? What happens if I break here? If I break here, I should get an empty dictionary because I never added him to my dictionary. But if I do add him to my dictionary, I get him here. And so if you're having trouble understanding the flow of the computations, I would say put some break statements in, print some things out, see what's happening. So here, for example, you might just say, what's my key, right? My key is master. What's my value, right? Because I know that up top my value is this whole thing, right? I know my value is this whole thing here. Okay. So I want to say for x and v lookup. Well, what's x lookup? So I'm going to say, okay, x lookup, right? X lookup is my action. And so, okay, so the first x is exit, right? So exit split is going to be 1. So it starts off, adds 1. And end character is going to be EXIT, so it'll be 4, right? And then here, I'm just going to add them. And, yeah, it's that easy. Okay, so here we go. I'm done with all my data. Boom. That's actually beautiful. So this tells me all of the action. Okay, so I want to get all of the dialogue. Well, I'm actually going to copy over all of this code. Well, I already did a few, and I'm putting it here. And I just changed one tiny thing. Instead of saying action, I said dialogue. And all the code stays the same. And that is the beauty of code, is that it's reusable. You don't have to write the same thing over and over and over again. Right? This thing is the same as before, except I have it for, it's dynamic, it's versatile, it works for lots of different things. It works when there's no dialogue, or works when there is dialogue. It doesn't get broken if things are empty. Yay! So if you got up to here, congratulations. You now have parsed through a pretty complicated document. You've gone through a Shakespeare play, and you've taken out some very interesting information from it. So I'm going to close off 3.5, and we're going to move on to analyzing stuff. Whoa. Okay, so we have our data from before, and let's go right into it. So if you love pandas, you're going to love them even more, because pandas is going to become your favorite tool to use in Python. So first, I'm not really going to explain too much about what's taking place just here, okay? This is a plotting library. This is pandas. I'll explain pandas in just a second. Don't worry about the notation so much, okay? Just run this, and we're basically saying, I want the pandas library, okay? I'm going to abbreviate it as PD. Pandas is, I thought when I first started that the guy who programmed it loved pandas, like, just made a program named after them. Turns out it's panel data. Panel data, like for stockbrokers to look at. It's like things that change over time. And a panel data, so up until now I've been using dictionaries. Dictionaries are really useful for like opening and closing and adding and subtracting. Panel data is something that's going to resemble something that you're more familiar with, I bet. And so just run this and have your mind blown. What? Yay! This is a data frame. It looks like the type of thing you see in Excel. It's basically a matrix representation. Right? You have your rows, you have your columns, you can do all sorts of fancy things. Don't really worry about what's taking place here, okay? We're basically just saying, give me a data frame. One thing I'll make clear is PD is standard. All right, this thing is pretty standard. Don't change this. As well as DF. DF is standard as well. If you want to name your data frame something fancy, I'd caution you not to, because DF is pretty universal. What I would say is if you want to name it something fancy, give it an underscore. All right, you could say fancy. Okay. All right. So here's my data frame. Now, this is beautiful, and we're gonna do all sorts of cool stuff. But I have an issue. My rows and columns are wrong. I need them to be the opposite. So that's actually really easy to do in Python. You just do it with two characters, .t, and this is what it looks like, right? You just switch them. T stands for transpose. It has to be capital. So, okay, great, but here's something I'm going to caution you against. What happens if I run this again? Whoops, transpose again. Oh no, it's not saved, right? So it's actually not fine. But what if I say df equals dft, and I print it, right? You see how it's going to go back and forth over and over and over again? That's actually quite problematic, because I don't know which way I started, which way I ended. So I'm going to tell you to do the following. First, let's run this again. Okay. So keep dependent code next to itself, meaning only transpose it if it's wrong. So I'm going to keep it right after I start my pandas, my data frame. So I would say if you're doing things that are dependent on each other, keep them all together. Okay, and this is what this looks like. And I can run this over and over and over again, because until I run this code, the df doesn't exist. Now it creates itself from scratch, now it transposes it, and now I print it. And this very beautiful print method with the hover, this is only available in a notebook. Okay, if you print it, it's going to look very ugly. It's going to look like this. Ugh. But it's actually not that ugly. If you print in other places, it can get even uglier. Okay, so print versus just displaying it, it's a lot more beautiful this way. Okay, cool. So just looking at it, right, this is this is not what I would call big data because it's small enough that you can kind of look with your eyes and count things. Big data is when I would say big data is when you can't look at it. So if we had the whole Shakespeare with every single character in every single scene, that would be big data. It would be too much. It's just small. It's one little scene. Okay, so I see which characters are spoken, how many things they've said. What if I want to sort things? I want to sort the values. So I can say sort values, and what do I want to sort them by? I want to sort them by the number of words, right? Let's just say the number of words makes them important. Well, there we go. So, it's backwards. So I have to say ascending equals false. False. No, whatever. Let's try first. Try it back. There we go. Ascending. So descending is big to little. Ascending is small to little. What a small to big. What I don't even know. I never even get it. Just Google it or just try both. Okay. Right. Just try one and be like, how does this look? No, that's not right. Change it. Right. The faster you can guess things, the faster you can write code. Great. So here we can say, who are the most important characters? Is it Boatswain? Is it Gonzalo? Well, here are the number of characters they speak, right? Here's the number of words they speak. Here's the number of characters. Here's the number of times they show up. They're all pretty related. So that's pretty cool. All right, before we go and start doing some more analysis, let's talk about summaries in Pandas. So Pandas are really great because they'll let you do some really powerful stuff without running a lot of code. But before we do any of that, let's do some basic stuff. So what type of data is a data frame, right? We know lists, we know dictionaries, we know all these other things. What's a DF? Well, we'll just type it. It's its own object. It's a Pandas core frame data frame. So if you ever want to evaluate if something equals the type of a data frame, it's going to get really messy. It's much easier to evaluate other types. Okay. How about a column? So if I want to select a single column, if I want to get I can do df, right, and words. So I'm going to put in brackets, get me the thing, and it's going to give me the number of words. There's also another way of doing it. I can just do by typing in without quotations, but this doesn't work if your thing has spaces. So I would say it's better not to use this method. It's better to use brackets and strings, but this way technically works, okay? So what type is a column? It's going to be a data frame? It's not. It's going to be a series, which is, and I'm not going to get into that, what exactly it is, but think of it as a column. It serves the same purpose. But it has a specific name and a very specific function. Okay, so now I know what a data frame is. I know what each column is. What are the types of the data inside of them? Well, you could just do df dot d types. Now the dot lets you get an attribute of it. So this data frame has attributes. It has data inside of it. You can say, tell me what types it is. The people who wrote the code for Pandas knew that you wanted to ask it these things, so they gave you a way to do that. So you don't have to write some complicated code. It's already there for you. So you do df.dtypes, and it's going to say the number of words is an integer, characters integer, and is integer. Boom. I love that. Okay, so I also want to do some other cool stuff. I could say df.info. Now notice dtypes does not have parentheses, and dfinfo does. Don't get too worried about that. A method has parentheses, and a characteristic has none. So if I want to say, what's your age, I just do age. But if I want to get, what's your average words per day, that's probably going to have parentheses. Okay, so dfinfo. This is going to give me a quick summary. So I'm going to say dfinfo, and it's going to tell me, you are a data frame. You have 7 entries, which means 7 rows, and it starts with master and ends with mariners, okay? Your data columns, you have 3 columns. They're n words and characters and instances. You have 7 non-null entries that are integers, okay? And here are the integers. They're integers 64. Great. And here's how much memory it takes. 544 bytes. Beautiful. Okay, how about describe? Describe is going to give me some statistics. It's going to tell me the count, the mean, the standard deviation, the minimum, the maximum, and all these other things. Not exactly what we need, but pretty useful too. Okay, a core is going to give me the correlation. How similar are everything's related? So, okay, the number of words is very similar to the number of characters, very similar to number of instances. As you can imagine, the more you talk, the more you're going to talk. And you can say, format it with this code here. And here we go, it's going to be blue to warm. Everything is red. Why is that blue? Yeah, everything is a very strong relationship. Oh, right, it goes from minimum to maximum. Everything is correlated, so that's obvious. Okay, cool. So we're done summarizing data. Let's move on to 4.3, which is calculating using groups. So let's just say I want to get the average number of average characters per word. So I don't have to go backwards to do anything complicated. I could do it the way you would do it in Excel. I could just say, get me the number of characters, and divide that by the number of words. It's that easy. And I can make up a name for this. I would caution you to making up names and change them, because every time you change a name, it adds the column. Oops, I didn't mean to do that, right? Still have that column. So what I would say, if you ever do this, just go to the beginning, reload, come back here. Well, actually, that's a problem because I didn't load the right one. Come back here. Oopsies. And then go over here, right? So don't rename your columns unless you absolutely need to. And if you ever rename a column, consider running your code from top to bottom again so you don't make any issues. Okay, so here we go. I've got my words, characters, and this is an average character per words. So who speaks with the biggest words? Master. Who speaks with the shortest words? Boatswain. And this is going to be something we're going to pay attention to. These sort of like little manipulations. Great. And what if I wanted to say, what's the value of the largest words per character per words? So I could just say, take the max from that column. And who has that max? I could say IDX max, which is take off the sunglasses, right? The ID of the person at max. So I'll say nmax and character. So who has the most? And master has the most at 6.375. That makes sense. Okay, so we are done doing some of these calculations here. Let's do some visualization. We're almost finished. We got 2 sections left, and then we're done. So this is how easy it is. We're going to say, let me take this column again, and I'm going to plot it. I'm going to do dot plot. A plot is a function, so it has parentheses. And what type of plot? I want to make it a bar plot. Boom. And this is the characters per word. What if I want to make this a title on the plot? So I could just say title equals. There you go. He's right there. How do you like that, baby? So you can see here that the average character per words, it's really hard to differentiate. They all look really similar, right? Master's got a whole bunch. Okay, so they're all pretty similar. How about I want to plot everything? I just don't want one. I want all of them. Well, okay, there you go. You got everything. You can't even see the average character per words because the number of characters are so big and these are so small. They're all sharing the same y-axis. So what I can do is I can say make my make my y-axis log, which means it's going to shrink it. It's going to make it, well, we're not going to get just into that, but instead of making it 1, 10, 20, 30, it makes it 1, 10, 100, 1,000, right? So it changes the scale. So now I could see more or less most of the data, and I could see, you know, I can't really see anything insightful here, just everything's too clumped together. Let's make another visualization. So I don't need to do a bar plot, I want to do a box plot. A box plot tells you the range of the data and what's an outlier. So here you have one outlier, right, for the number of instances. So there's one character that shows up a lot, more than everyone else. And let's see, and instances is going to be, it's Gonzalo. He shows up way more than everyone else. In fact, you could say he's an outlier. So boom, you know, you could say right off the bat, Gonzalo is Shakespeare's most important character for the scene. I mean, that would be a reasonable conclusion if you wanted, but we're going to do some better analysis. Okay. Now, what if I want to go through each column and loop through them? So I could say, and ignore the color dictionary for just right now. I'm going to say, for each column in the columns, plot that column. And now I'm going to look up the color, right? So I'm going to say, go into color dictionary and look up the color. And I made a color for each one, okay? And then I'm also going to give it a title. I'm going to say the title is going to be the column, and the color is going to be the same color, okay? And I'm going to show it at the end, because otherwise it's going to override each other. So there we go. So and words, right? And characters, and instances, average character per words. So you can take a look at these. Let's see. Let's take a look. Let's take a quick look. Botswana and Gonzalo speak almost the entire time. Everyone else speaks very little. And that's similar with their characters. That's the number of characters are very similar. Number of instances, it's actually pretty beautiful. It's this nice little bell curve here. So Botswana is there for most of the story. He's probably the glue for the narrative. Then you have these other guys who don't really show up that much, and Gonzalo's there a whole bunch as well. For how many lines they're total. And characters per word, it's really hard to distinguish anything meaningful from here. So really can't see anything. Okay, I don't have to do just a bar plot. I can do a scatter plot. So let's say I want to do number of words versus characters. So I can just do that here. And this is going to be the number of words versus the number of characters. It's a straight line, which tells you however much you speak, that's kind of how long your words are. Pretty obvious. Well, maybe there's some tiny fluctuations, but nothing that we can decipher. How about the number of instances? How about the number of words versus the number of times you show up? And here you go. So the number of times you show up is more or less going to be equal to this line here, except for this guy here. There's one person who doesn't have a lot of words, but shows up quite a few. So he's probably like the messenger type of character. That would be obvious. So maybe you would expect a trend that looks like that. Okay, so we're done playing around. This has been very fun exploration. Let's be a little bit more focused. So in order to be focused, we need to ask ourselves the question. What are we trying to figure out? So I'm going to suggest that we try to figure out who is the most important character. And do evil characters have specific patterns? So the way we're going to do that is we're going to see, can we decipher who has the most time on stage? And is there a way that this person talks? So first I'm going to make a nice little deep purple. I'm going to say this deep purple is here. I'm going to say, plot for me the number of words, okay? So boom. Number of words, this is going to be my first conclusion. I've got these two characters. Which one is more important? Okay, so let's try to figure it out. I'm going to create two new columns. I'm going to say words per instance and characters per instance. Because I know how many times you speak per word, but what if every time you say something, you say very little or say a lot? Let's take this. Let's take a look at that. So, okay. And now it really shines out. Because even though Gonzalo doesn't speak as many times as Boatswain, right? When he does speak, he says a lot. He's got a lot on his mind. Oh my gosh, look how much he says. He's saying these long words, lots of words, lots of characters, right? He's saying 21 words for every time he shows up. This guy is not here to say hello, goodbye. He's here to tell you his thoughts. So this is either someone conspiring. There we go. So he's either someone who's conspiring or he's someone who's there to defend themselves, I would suggest. So I would say Gonzalo is really important. This is someone who's really going to have importance during the story. This is going to be the words per instance. And actually, let's make this the title. Okay, title equals, there we go. Words per instance. Nice. And I want to say, give me the characters per instance. Right? And they're very similar plots. So that's good for us that we don't have to reconcile any things we found. This little thing here, ignore it, right? If you want to get rid of that, you just do plt show. And it's gonna show up neater without that little error, without that little ugly thing there. I don't need to know that you've created an object. Great. So I'm almost done. I want to, what if I want to plot both of these things next to each other? So I can just say, select both these columns, and these columns have to be in a list. So here, I'm not going to select one column and then the other. I have to put them in a list together, so they have double brackets, okay? I'm also going to give it the color 2 colors, because I don't want them to be the same color. I'm also going to give it the title, The Tempest Act 1 Scene 1, okay? There we go. So here's the characters per instance and the words per instance. So you see who's really speaking the most is Gonzalo. Even though he might have the most words, he might not have the most characters, he might not have the most instances, but when he's on stage, he's talking a whole bunch. So this is very clever stagecraft from Shakespeare in that he's creating characters that are intriguing. They've got a lot to say, but maybe they don't have as much time as we would like. This is a great way to get us to listen for scene 2. And if you wanted to save this, you would do as follows. You would do plt save fig. You give this would be the name of your file. So I'm naming it. I'll name it this. I'll just name it. And I would get rid of any periods in your file name except for the end. So I'm going to call it The Tempest Act 1 Scene 1 PNG. I'm going to give it the data, the pixels per inch. Can name 150. And I'm going to say beatbox inches is tight. If I don't do that, the bottom's going to get cut off. Okay, it's going to cut off these characters. I'm just going to say type. Now, if I do this, my image is going to save blank because I already when you show the image, it gets used up. So I'm going to comment that out, and now I'm going to save it. And if you go to this folder here, this is now here. Okay, Google's not going to let you view it. You're going to have to download it manually, so you could just say download. Okay, and now it should be in my downloads. Yep, download it. And I'm going to open this up. How cool is that? So now you can share this on your social media and say, oh my God, I'm a data person. Look what I found out about Shakespeare. I just uncovered the secret of the universe. And anyone who works in data can argue with you, but they can also do the analysis themselves. And then you can have a polite conversation about the results you got. So I would also not save files over and over again, just because it can get very computationally heavy, and also like takes up space. And I'm going to just show it again. So if you save it, you don't show it. If you show it, you don't need to save it. You shouldn't save it. Okay. So we're done here. So let's make some conclusions after our analysis. Yeah, we've spent a whole bunch of time. Let's come up with some conclusions. So here's some conclusions I've got. I've got Gonzalo has the most words per instance. And he also has the most characters per instance. He also has few characters per word, which is something a little bit interesting. This is more than Botswan, but less than Master. It's hard to say if Gonzalo's evil or not, but he's certainly important. How intriguing. So with that said, congratulations, you've now finished Module 2, Interacting with Data. I hope that you understand all of this and that you are finding it meaningful and exciting. If not, take some time to look over some of this code and feel free to ask me any questions, reach out to me on whatever. I'm going to, yeah, that's all I got. So enjoy and keep on learning.